Hey, this is Dr. Thomas C. with Science in Seconds, and we're celebrating an anniversary today. It's the 9th anniversary of the launch of Juno. And with me here to talk about not only Juno, but 3 new publications that just came out are Scott Bolton, the PI of Juno at Southwest, and Heidi Becker at JPL, who's the lead of the radiation monitoring group. Scott, what's new?
So we've got 3 new papers coming out, and they deal with the topics of lightning. We found some lightning really high up, much higher than we expected. And we've also developed a theory that shows that hail is pretty common from violent thunderstorms at Jupiter, and it's carrying ammonia and water down deep into the atmosphere. And these are really exciting results because most of the weather and meteorology on Jupiter is driven by ammonia and water. And on Earth, it's all driven by water. But on Jupiter, it's a little bit different. Ammonia starts playing a really important role.
So Heidi, talk to us about these hail balls. Talk to us. How should we imagine them?
Well, they're very large. They're at least as large as a softball, maybe quite a bit larger than that. And on the inside, they're made from a pretty unusual ammonia water solution. It's kind of like a Windex snow cone, if you can imagine that, covered in a hard water ice crust that gets thicker and thicker and thicker the longer it's tumbled in the atmosphere by Jupiter's violent storms, until they get so heavy that they fall deep into the atmosphere and carry the ammonia down deep.
So Scott, one of the most amazing views, of course, are these images that so many of our citizen scientists worked on, which is this beautiful, highly structured atmosphere, really, of this planet. And I'd like to understand, is this structure kind of further in, or is it on the inside? Is it more like, uniform, or how should I think about these kind of weather observations here?
So that's one of Juno's discoveries, is we're seeing that this stuff goes down pretty deep. Before Juno, we thought that all those beautiful clouds and zones and belts and the winds on Jupiter were just skin deep. But in fact, they go down quite deep. And so what you're seeing at the top cloud layer is really the very top part of a storm that has really deep roots and is violent thunderstorms with lightning and strong winds.
That's amazing. So Heidi, how did you actually discover this? What's the instruments you used for this?
Well, we actually used our engineering star camera to do it. It's there to help us navigate Juno and tell us where we were pointing when we took our data, but it's incredibly sensitive. It can see very dim things, and because Juno flies so close to the cloud tops, we were able to see lightning flashes that were much smaller than any prior mission had ever been able to see.
So Heidi, what's the most exciting part of this discovery for you personally?
Well, for me personally, it's the realization that lightning on Jupiter isn't happening the same way it happens like it does on Earth. That's what everybody thought. Looking at images from back to Voyager 1, everybody thought it's made in the deep water cloud where thunderstorms are like they are at Earth. But these altitudes where we're seeing them happening, these small lightning flashes, it's happening where you can't have liquid water, but there's something special in Jupiter, which is ammonia, and that acts as an antifreeze that allows water ice to melt at those high altitudes and create the conditions for lightning. So it's very exotic and very different than what we have here on Earth, and that's what's most exciting to me.
Scott, Heidi, this is just an amazing discovery, and I just want to congratulate both you and the entire team for this amazing work during the last 9 years, and also for the years to come, as we observe the amazing hurricane on the East Coast that just went over our house here. Of course, it's just amazing to think that out there in the solitude of space where Juno makes observations, there is violent weather of type that we've never observed here, and that's exactly why we do these amazing missions, is to learn about nature itself in other places. So thanks to you and congrats.